Hey guys, this is presentation 2. We were asked to go through the derivation of the Michaelis-Menton equation. This is the equation we were, This is the equation we were given here. So I'm just going to walk through step by step. The equation here, I just want to explain a little bit. We have the enzyme here plus the substrate. And sorry, I have to take the notes. K1, the enzyme plus the substrate reacts and then forms the enzyme substrate complex. K1 is the constant rate when the reaction is going this direction, and then the K minus 1 is the rate of the constant going backwards. And then we have the enzyme substrate complex going forward to produce our enzyme plus our product. And K2 here is the rate constant of the second step. So it's this step going forward. And we also should have a K minus 2 down here, and that would mean it's going this way. So the initial velocity, which is determined by the O here, is equal to the K2, and going back, the K2 is the constant rate of the second step, this part right here. And the problem is we don't know the enzyme substrate complex because it forms during the reaction. But we can make an assumption that it's a low concentration and it doesn't change because the rate of its formation is equal to the rate that it breaks down to. In mathematical terms, I can write this down. I can write what I just said down, and it is K1 E, our enzyme, and then our substrate is equal to our K negative 1, which that's the backward step, and then our enzyme substrate complex plus the K2, which that's the rate of that second step, times the enzyme substrate complex. All right, there we go. All right, so after given this equation, we realize that we don't know what the enzyme is here. And this is the concentration of the free enzymes. We do know that the free enzymes and the bonded enzymes are equal to the total enzyme concentration. And that is written here in equation form as the enzyme total is equal to the, oops, that's an E, enzyme plus the enzyme substrate complex. So we have step 1 here, kind of step 2. I'm trying to write nicely, sorry. So this third step I've written here, we need to substitute the total enzyme into this steady state equation and then rearrange, and we're just solving for ES. So we just did some algebra here and we're solved for ES. This next step here in red, we have taken this equation and we need to rearrange it to isolate the rate constants and then replace those constants with the new constant right here, and that's called the Michaelis constant. Earlier we were given the kind of the first step here. We were given this equation, and here our next step is we're substituting the value of the enzyme substrate complex into this rate equation. I also like to mention that K2 can also be called the catalytic constant, Kcat, because it represents the rate constant for the reaction. Our final step here is the maximum velocity, which is Vmax. Oops. Times our substrate. Vmax is equal to the total enzyme concentration times the catalytic constant. We're substituting Vmax into the equation to get to the final form of the Michaelis-Menton equation written here. plus our substrate. Alright, I hope you guys enjoyed my presentation. Sorry for the sloppiness. If you have any questions, please let me know. Thank you.